2.5 transformations of functions preparation. Use the graph of f of x is equal to the absolute value of x to obtain the graph of g of x is equal to the absolute value of x minus 3 and absolute value plus 1. Okay, so the original one should look something like this. There we go. And this right here. Okay. So that was the original one. Okay, let's see what the new one is. And typo again. Okay, so this should have been the absolute value of x minus 3 and absolute value plus 1. Okay, so positive 3 in here. So I need to break this up again. So I'll break off the negatives up the top, and I'll put the positives on the bottom. All right, and then over here we'll do positive 1, positive 2, positive 3. All right, so if I do a negative 3 minus 9 is negative 6. Absolute value of negative 6 is positive 6. 6 plus 1 is 7. Negative 2 minus 3 is negative 5. Absolute value of negative 5 is positive 5. Positive 5 plus 1 is 6. Negative 1. Negative 1 minus 3 is negative 4. Absolute value of negative 4 is positive 4. Positive 4 plus 1 is 5. And so on and so forth, right? So 0, 0 minus 3, negative 3. Absolute value of negative 3 is positive 3. Positive 3 plus 1 is 4. 1 minus 3 is negative 2. Absolute value of negative 2 is positive 2. Positive 2 plus 1 is 3. And hopefully you see the pattern now. 2 minus 3 is negative 1. Absolute value of negative 1 is positive 1. Positive 1 plus 1 is 2. And 3 minus 3 is 0. 0 plus 1 is 1. So on and so forth. I probably don't have enough points there, but hopefully you kind of get to the point that was being made there. Okay, so let's see what this looks like. So negative 3, 7. So negative 3, positive 7 would be right about there. We would say negative 2, 6. So negative 2, 6 is right there. It's like here, here, here. And if we would have had more points, we would have found this pattern right here. Oops. There we go. So we would have found this pattern right here. Okay, so this just combines the vertical and horizontal movements of the previous one. So in this case, if you just look at the bottom right here, this little point right there. So what happened is, because of the negative 3, it moved 3 to the right, and because of the positive 1 right here, it moved 1, 1 up. Okay, and sure enough, it went up 1, and then it went to the right 3. Which is exactly what you would have predicted, given that, right? So 1 up and to the right 3. And that is the both the vertical and horizontal transformation of that. Okay. Okay, so let me do the original one on this one. Should have looked something like that. There we go. And like that. Okay, so that was the original one. Now, without me actually filling out that chart, let's see if we can figure this out. It's adding 2 here to the x's, so it's opposite looking. So it should go 2 to the left. And because I'm subtracting 3 here, it should go 3 down. So these points should move. Right? There was originally a point. Maybe I should have done the black one first. So there was a point there. There was a point there, there, and there, as well as here, here, and here. So I should just be able to shift those, right? So again, 2 to the left and 3 down. 1, 2, 3. 2 to the left, 1, 2, 3. 1, 2, 3. Now, 1, 2. So 2 to the left and 3 down. 2 to the left, 3 down, 1, 2, 3. To the left, 3 down, 1, 2, 3. To the left, 1, 2, 3 down. 2 to the left, 3 down. Messed up on that one. Let me fix that. Okay. So that little point right there. So, oops. So 2 to the left, 3 down, 2 to the left, 3 down, 2 to the left, and 3 down, and finally 2 to the left, and 3 down. 1, 2, 3. Right there. And yeah, that should do it. So we should be able to draw it, and it should basically be the original, but because of this, it shifted 2 to the left, 2 to the left, and 3 down. And that's what happened. Use the transformations of f of x is equal to x squared to graph the following function. Okay, so this one's going to be the base function. All right. Which looks something like this. But using the transformation, we know that because this 2 is being added to the end, I'm going to shift everything up 2. Everything's going to be shifted up 2. Okay, so this point goes up 2, this point goes up 2, goes up 2, goes up 2, goes up 2, and this just shoots right off the top because my paper's not that big. And then when I graph it all out, sure enough, it should look something like this right there. So that just transforms it up 2. Now I'm going to graph the next one. Okay, fine. So this one over here, it originally had the same kind of graph originally. This was the parent function of x squared, basic parabola. Okay, now because I'm subtracting 2 here, this means it's going to go down 2, because I subtract 2. And that's subtracting 2 from there, which is really y. Just like over here, this is kind of, you can think of this in terms of y, and this is really adding 2 to y values. Okay, so in this case, I'm subtracting 2 from the y value. So all these points are going to go down 2. They go down 2 points. And sure enough, if I draw a graph through these, it should look really close to the original graph. Just if you shifted it, whoops, if I shifted it down 2 points. Okay, so let's try the next one. Use the transformation of the graph of f of x is equal to x squared to determine the graph of the given function. Okay, so we can draw the original ones, which would be here, 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 and we would have one here, and we would have one there. So it should be like that. It should be, oops, like that. We do the same base one over here because I know I'm going to need it, so I might as well get it out of the way now. There we go. And it's symmetric. Okay, so this one right here, because I'm subtracting 6, it's going to make it go 6 to the right. Because on the one over here, I'm subtracting 4, it's going to make it go to the right 4. So it's the opposite look. Whenever you modify the x values, it has kind of the opposite looking effect. So we simply shift all these points over 6 to the right, 6 to the right. So every one of those points gets shifted 6 to the right. And sure enough, if I graph it, it does look like all these were shifted. Okay. Now what about this one? This says we'll shift them all 4 to the right. Same kind of structure, right? We just rewrite all these. Shifted to the right. And if I draw a graph through it, there we go. Okay, and if you look, sure enough, all these points were shifted 4 to the right.